Okay, so the Unit 4, Section 4, it says angle measures and segment lengths. And our goal today is to apply the rules and theorems of segments to solve for like X and Y. So we're going to try to solve for X and Y in these circles. So at the top, you see there's two theorems that we're going to use to answer the questions from the first section. And theorem 1 is the measure of an angle formed by two lines that intersect inside a circle. So if we have two lines that intersect inside a circle, is half of the sum of the intercepted arcs. That looks kind of confusing. So we're talking about angle 1. This angle right in here, inside of the circle, is half of these two, the two across from it, the two arcs. So basically, if I know this and this, I can add them together, divide by 2, and I have this angle right here. So I can add those two arcs together and divide by 2. And that's what they're saying here. Add the two arcs together and multiply by 1/2. Same thing as adding the two arcs together and dividing by 2. So we're doing the same thing there. Theorem 2 tells me if I have an angle that's outside of the circle, so it's way out here, then what I do is take the two arcs that it touches and I actually subtract them. I take the bigger one minus the smaller one, and it's half of that. So notice the difference. If the angle is inside of the circle, I take the two arcs and add them and multiply by 1/2. If the angle is outside the circle, I take the two arcs and subtract them and multiply by 1/2. So there's the difference. Inside of the circle, I'm adding them times 1/2. Outside of the circle, I'm subtracting them times 1/2. So let's look at example 1. In example 1, 2, and 3, they're all inside the circle, right? So we're inside the circle. So A, B, and C. So example 1, we're trying to find the measure of angle 1. So the two angles that go with angle 1 are 50 and 42. So angle 1 is going to be half of 52 plus 40. I said 50 and 42. I meant 52 and 40. So half of 52 plus 40. Well, 52 plus 40 is 92. So I want half of 92, which is going to be what? We got our calculators for today. 46 degrees. So the measure of angle 1 is 46 degrees. Again, it's half of those two arcs added together. Now, you can look at this one. It says, what is the measure of angle 5? Okay, so angle 5, we have here, there's an issue here. First of all, I'd like to find the measure of this one, this angle. Okay, so to find the measure, that's not angle 5, but hold on. But to find the measure of this angle, I'm going to say 130 plus 90. And it's half of that. So that's half of 220, which is 110 degrees, is the measure of that angle. Now, if this angle right here is 110 degrees, and this is a straight line, what do these two angles have to add up to? If that's a straight line, 180. So if I know that this one is 110 degrees, I can do one more math here. 180 minus 110 means angle 5 has got to be 70 degrees. So even though I didn't know the arcs for angle 5, I knew the arcs for the other two, and then I got that one, and I was able to subtract it from 180. So I'm still able to it's the same as we've been doing the other days. I'm still able to kind of piece together the puzzle here. Okay? Same thing happens right here. Same thing. Let me find this angle. Well, to find this angle, I got to add these two together. So half of 56 plus 146. That's half of 202, I believe. And half of 202 is 101. So that tells me that this angle right there is 101. Well, if that angle is 101, those two create a straight line, which means they got to add up to 180. So if that one's 101, I say 180 minus 101. What's the other one got to be? Yes, 79 degrees. So we're able to, again, in A, you saw where we were just finding the angle that had the two arcs right across from it. We're able to just take half of those two. Then in B and C, we had to find an angle where they had the two arcs across from it, and then understand that we had a straight line there, so we could subtract from 180. So there's a little bit of math, there's a little bit of math going on in example 1 to try to find that. Now in example 1, notice all of the angles are inside of the circle. So notice what we were doing was adding them together, right? And then multiplying by 1/2 or dividing by 2, however you want to think about it. Now what we're getting ready to do in this second example is when the angle is outside of the circle. So in example 2, it says find the following angles. I want to find the angle called MPN. Well, MPN, if you follow that, MPN is all the way across. So basically from here to here to here. So we're looking for this angle, the one out here, okay? I know that this is 34 and this is 18. So if you go back to that formula they said, you subtract those and take half of it. So we say 1/2 of 34 minus 18, right? And 34 minus 18 is 16. So what's half of 16? 8. So it is 8 degrees. You can see that's a very small angle, right? You can tell it's really small, so you know that it's going to be a small number there. So we get 8 degrees for example 2A. Let's look at B. Same thing. What are we subtracting? Yeah, so 80 minus 40. 80 minus 40 gives us what? 40. And half of 40 is? Yep, 20 degrees. So we're left with 20 degrees as our answer there for B. So again, we're doing some pretty basic stuff there. We're subtracting them, dividing by 2. That's nice. Now, hold on a second, we get something crazy happens. Well, now we get the angle, but we don't know this. So now we're like, oh no, we're in trouble. So now we say 70 equals 1/2 of the big one, W, minus the small one, 110. Okay? Now, let's think about that. This looks like an equation now that we would do, right? It looks like kind of an equation we would do. So let's think about what the equation would be. Well, 1/2 times W is just half of W, minus 1/2 times 110 is 55, equals 70. And you know what we're trying to do? We're trying to solve for W. So let's move the 55 over. So we want to add 55. That's going to give me 125 equals half of W. If I have half of W, what do I need to do to solve for W? Huh? If I got a number on the bottom, I'm going to get rid of it. So I'm just going to multiply by 2. So if I have half of something and I want the whole thing, I got to multiply by 2. So half of W, I'm going to times 2 on both sides. So W equals 250. Now, that should make sense because look at the problem. If I make W 250, think about how you do this. 250 minus 110 is 140 divided by 2 is 70. That's how you get the angle on the outside. You subtract those two and divide by 2. So 250 minus 110 gives you 140. And then when you divide by 2, you get 70. So that actually makes sense in that problem that you would do that. Okay, I'm going to set these up for you real quick, and then we'll see what we can do. In these, I'm going to give you in B and C. You need to know all the way around the circle is how many degrees. All the way around the circle is how many degrees. If you turn in a complete circle, how far did you go? Yeah, 360. So if you do like a 360, that means you spin all the way around in a circle. Half of it is 180. If I go all the way around, it's 360. So you got to know that all the way around the circle should be 360. So if this is 110 and this is 100, that's 210. And this is 80, that's 290. Then I know what this is. This is 70. Okay, so I'm going to fill in the missing parts there. If this whole area is 220, then I know what this missing part is here. It's going to be 360 minus 220. Okay, that's all they asked for, see? In B, they asked for this. So remember, it's going to be 1/2. So x is going to equal 1/2 of 100 minus 70. So you can solve that one. In this one, we have 20 equals 1/2 of 70 minus x. The big one minus the small one. So let's try to solve that one. Okay, you're doing an equation. That's all you're doing. I'm going to let you see if you can get A, B, or C. I'm going to give you just a couple minutes, and then we'll come back. In number 1, we already said in C that it was simple, that we just had 140. We just subtracted those because we know all the way around the circle is 360. In B, we said if we add all these up, this had to be 70 because all the way around the circle is 360. And we said half of 100 minus 70, which is 30, is going to be 15. So we got that one, 15 degrees. Now, here we're going to say 1/2 times 70. What's half of 70? 35 minus half of x. Okay? So you have half of 70, and then you have to also distribute the half to x. So we're going to subtract 35 over to the other side. Subtract 35. We get negative 15 equals negative 1/2 x, and I'm almost running out of room. But now, if we had 1/2, then we solved it by multiplying by 2, right? So if we have negative 1/2, we can solve it by multiplying by negative 2. So we just multiply by negative 2. So if you multiply by negative 2 to both sides, what's 15 times negative 2? 30. So x equals 30 is my final answer. And think about that. See if that makes sense. Here's the angle that's 20. 70 minus 30 would be 40, and half of 40 is 20. So it makes sense. So that answer works for our angles. So the U-try does make sense on there. So you should be able to get those. Okay, so what you've done so far is when there are angles inside, you add the two arcs and multiply by 1/2. When there are angles on the outside, you subtract the two arcs. And on page 2, there's a couple more theorems that we're learning as we go through this. And the first one is, we're still talking about the same type of thing, but in the first one, we learned if these things just cross each other, the chords, if they cross each other inside the circle, we could just multiply them. A times B equals C times D. So we could figure out their lengths. Because notice, these lengths aren't the same. This one's longer, this is shorter. These are not the same. So to figure out their lengths, we can say A times B has to equal C times D. So if we multiply them, they've got to equal each other. Now, this is an interesting one here. The number on the outside gets distributed into both. W times W plus X is equal to Y times Y plus Z. It's going to be kind of interesting. Here, the one that hits the line, you square it, and it's equal to Y times Y plus Z. So the number on the outside is the one that gets distributed when we multiply these. So we're going to go through each type, kind of look at them one at a time, and try to answer those questions. So let's look at example 4. There's 3 of them in here. In example 4, let's go to part C first because it matches up with our first theorem. So part C is telling us to multiply. Okay, this is 6.5. This is M. This is 3. This is 7. So 3 times 7 is equal to 6.5 times M. That's what it's saying. This times this equals this times this. So one line multiplied has to equal the other line multiplied. So 3 times 7 is 21. That equals 6.5 M. And it's okay to get fraction or decimals and stuff now. So it's okay. We're going to get a bunch of decimals here in just a minute. But when you divide by 6.5, you are going to get a decimal. 21 divided by 6.5 gives you about 3.2. And that is your final answer. So that's how you figure that one out. We're just plugging it in here. We said we knew you have to multiply the 2 lines, the 2 parts of the line together, and then set them equal to each other. So that's the goal, and that's all we're doing there. Multiplying them together and set them equal to each other. Let's work our way backwards. On B, we're going to say this, it looks like this, right? So this squared, so Z squared equals the number on the outside distributed into both of the numbers. So you see how I set that up? The part that's just by itself has to be squared, and it's going to be equal to the number on the outside distributed into both numbers. Okay? So don't make it harder than it is. It's just a formula to follow. So Z squared equals 8 times 8 plus 16 is 24. So we're going to say Z squared equals 8 times 24. And that is 192. And then how would we solve for Z here? Square root. So square root of 192. Now that does not come out evenly, but we'll round it to 1 decimal like we've been doing. So when we do the square root of 192, we can get 13.9. Okay? So anytime you put it in a calculator, if it doesn't come out evenly, just like it did in the other one, you can round it to 1 decimal place. So we end up with the answer of 13.9. And we've got that. So now we have the other, there was the third way of doing it. So there's 3 different things that we were learning up there, and that was the third one. Okay, the third one says, that's the one where we're going to distribute what's on the outside into both of them. So the 6 is on the outside, right? So 6 times 6 plus 8 equals, 7's on the outside here. 7 times 7 plus y. So we're just going to distribute what's on the outside to both parts of the line. So let's think about it. 6 times 6 is 36 plus 6 times 8 is 48 equals 7 times 7 is 49 and 7 times y is 7y. So it looks like a lot, but it's really not. We're just adding and subtracting, and then we're going to divide at the very end. So we're just doing It all goes back, no matter whether we're doing circles, quadrilaterals, absolute value, whatever unit we're in, it all comes back to solving an equation. So we take 36 plus 48. We're going to add that together on the left side, and we get 84 equals 49 plus 7y. Then we'd like to subtract the 49 over, right? We want to subtract the 49 over to the other side. And 84 minus 49 is going to give us 35 equals 7y. Almost ran out of room, just had enough. And then lastly, we want to divide by 7. What's 35 divided by 7? 5. So we end up with y equals 5. And that's our final answer. Now, the way we know to do each of these three problems, the way we did it, is by these formulas. You'll have this on the test, okay? So you don't have to memorize it. So you'll see this, this, this. You'll see those pictures of telling you how you do it. Okay? You just have to understand which problem we're talking about. You got to understand that first picture on the left is talking about C. The one in the middle is talking about what we just did in A. The last one is talking about B. And we just got to apply it to the correct problem. But you're going to get that same thing. Okay? So with that, we move to a crazy looking circle that has a bunch of different things on it. And so we'll scroll down. And they put everything together in this U tried down here. Notice, first, we see the Y. Think about if we were just looking for this Y right here. How can we get this angle if we know these two arcs? What do we have to do with these two arcs to get this angle? You got to look back from page 1. What do we need to do with those two arcs to get the angle in the middle? Yeah, you got to add them up and then divide by 2, right? Or multiply by 1/2, either way. So y is going to equal half of 85 plus 45. So that's how we can get y. Y is going to be half of 85 plus 45. So let's go ahead and say, okay, well, let's add those up. So 85 plus 45 is 130. Half of 130 is just 65. So y is 65 degrees. So we got y. We got that part done. All right. Now, let's look at the second part, which is, let's look at z, for instance. So z is this line inside the circle. How much is it all the way across? Think about it. Just the part inside the circle, how far is it? $15. So this line is 15, the part inside the circle. Part outside the circle is 6. So let's say z squared, because you know it's that one part, equals the part outside the circle distributed into both parts. Okay? The part outside and the part inside. How you solve for that one. That's that one that we just did in the last set of problems. So, we're going to distribute the 6. So 6 times 6 is 36. And 6 times 15 is 90. So we get z squared equals 126. And when we take the square root of 126, we will not get a whole number. So we don't get a whole number there. We're going to end up getting a decimal, which is okay, not a big deal. We get a decimal, and we get 5, or what do we get? 11.2, sorry. 11.2. Now, let's look at the last one. I actually thought the last one was the easiest one. That's the one where you multiply the lines. Let me take this 15 out here. this times this equals this times this. So 10 times x equals 6 times 9, right? Those are the two parts of this line, 10 and x. These are the two parts of this line. So 10 times x equals 6 times 9. So 10x is what we have on one side. And on the other side, we have 6 times 9. That is 54. So 10x equals 54. We just divide by 10. So we get that x is 5.4. So now, we use 3 different formulas to get x, y, and z. So to get x, we multiplied the lines as we went across. To get y, we did adding the two arcs and dividing by 2. And to get z, we did the one where you have a chord on the outside, so you did z squared equals the part on the outside times both parts. Okay? And that gets us through solving that whole circle. So basically, they want you to do that so that you can use all of the ways that we learned in the last page and a half, all in kind of one problem. I'm going to set up these last 6 and then ask you to kind of solve them. 15 and 16 look like the one where obviously what we're going to do is multiply the two lines. So 8 times x equals 20 times 6. And you're going to solve for x. So that's how I set up the first one. Number 16, 26 times x equals 15 times 20. And I've set up the second one. So I really like those because you can just multiply them together, solve for x. Okay? This is the one where 2 things are on the outside. So is number 18. But this is the one where 2 things are on the outside. So 11 times both of them, 11 plus 20, equals 13 times both of them, 13 plus c. So you set it up and you're going to solve for c. Okay? Let's keep going. Number 18. This one looks a little trickier. It says in number 18, the whole side is 6. So we're going to do 3 times 7 equals 6 times x. That's all we have to do to solve that one. Okay? Then I'm going to go to number 19. In number 19, we're going to do the outside here. We're going to say 7 times 22, which is the whole thing. So I should let me give it to you a little bit better. 7 times both parts, the part on the outside times both parts, equals, okay, 5, because 5 is the part on the outside, times both parts, 5 plus x. That's how we solve that one. Okay, and lastly, we go to 20. It's the one with that one side. So 11 squared, that one side, equals the part on the outside, 7 times both parts. 7 plus what? This whole line, x plus 5. Looks kind of weird. And that's how it works. Okay? So remember, when you have one on the outside, you do the outside squared equals this part, 7, distributed into both parts, 7 and this whole line, which is x plus 5. So you'll be able to solve for x in those. So in 15 through 20, you will be able to solve for the variable. Either, in most of them, they got it labeled as x. In a few of those, they have it as y. If you notice, in number 19, they have a y also up here. That's a different formula. It's one by itself, so it would be y squared equals, and remember, it's the outside 7 times the inside. 7 plus 15, the whole thing. Over here, if you needed to find y, you would say 9 times y equals 5 times x. But you need to plug in your answer for x. And you would get the answer for x by solving this down here. So you do that first. Okay, so take a little bit of time. Take you 5 minutes or so to try to work your way through it. You need to work through these. If you don't work through these, not going to help you later on. So you need to try to work through them, and then we'll come back. In question number 1, remember you're going to say 8x equals 120. What do you get for that one in 15? When you divide by 8? Anybody? You get x equals 15, right? 120 divided by 8. Okay, in number 16, we say 26x is equal to 15 times 20 is 300. We're going to divide by 26. So we do not get, again, we're not going to get a whole number there because we're taking 300 and dividing it by 26. So we get 11.5 if we round it to that one decimal place. Okay, over here in 17, say 11 plus 20, again, that's 31 times 11. This is 13 times 13 times 13 is 169 plus 13c. Okay, 11 times 31 gives us a big number here, 341 equals 169 plus 13c. I'm running out of room. Now I must subtract the 169 over here, and that's going to give me 13c equals 341 minus 169 gives me 172. And then when I divide by 13, I should get like 13.2. Okay, I know that was a lot right there. Down here, 3 times 7, this is an easy one, 21 equals 6x. So then I just divide by 6. So x equals 21 divided by 6 is 3.5. So I just get 3.5. Here, I could say this is 7 times 22, and this is 25 plus 5x. And I just need to find what 7 times 22 is. That's 154 equals 25 plus 5x. And now I can subtract 25. So I get 129 equals 5x. Again, I'm going to get a decimal because I'm going to divide by 5. So I get a decimal, it's like 25.8. So x equals 25.8. In that one, I had a y also. So to do the y, it's going to be 7 times 22. Y squared equals that. Well, we already found what 7 times 22 was down here. It's 154. So y squared equals 154. And we got to take the square root of 154. So y equals the square root of 154, which is 12.4. Again, I told you before today, I said there'd be a lot of math coming through this one. 20, the last one. Let's do the last one. 11 squared is 121. Now look at this. Distribute the 7. 7 times 7 is 49. 7 times x is 7x. 7 times 5 is 35. So I distributed that 7 into everything. Now, I can add the 49 and 35 together. So that is 84. And then I need to subtract the 84 over so I can solve for x. So I'm going to minus 84 from 121 so that I can solve for x. So 7x equals 37. Again, I'm about to run out of room. Divide by 7, you get 5.3. So x is 5.3. My answer there. Now, notice what that other problem was. 9 times y equals 5 times x. Here it is. And I said, plug in your answer for x. So 9 times y equals 5 times 5.3. That's 5 times 5.3 is 26.5 equals 9y. And then finally, the very last thing we do is divide by 9. So 26.5 divided by 9 gives me 2.9. Again, there's a lot of steps, but we're piecing together the puzzle. That's all we're doing. We are adding, subtracting, multiplying, and dividing, and we're doing so with pretty small numbers. Our answers can be decimals, but they're not huge numbers. They're no crazy decimals. Things work pretty perfectly. So we have the key things where we're multiplying the lines and setting them equal. The key theorems that we're supposed to use are given to us. The equations we're supposed to use are given to us in the notes. And then we take those equations and we use them the best way we know how to solve the problems. And that's really all we did through today's work. So today, you're going to go back to IXL. There is a circles mixed review. And I'm going to go through real quick. Let me show you. Before you start, I need you to look up so you see it, what you're going to be working on. So let me take this off the screen later. But the circles mixed review is a lot easier. So if we go back to, we can jump levels, we can go down levels. If we go back, again, if we're looking for an arc, we know all the way around the circle is 360. So if this one's 80 and this is 140, then we can figure out what this is. We have to subtract it from 360. If we miss it, we understand that all three arcs have to make up the whole circle, and they all got to add up to 360. So if we know two of them, we subtract from 360, and we now know the last one. Okay? If we want, when we move forward, like I said, maybe they give us the radius, and it says, what is the area? Oh, well, we got to remember a couple things. We got to remember two formulas. The circumference of a circle is 2 pi r, and the area of a circle is pi r squared, right? So if we have the radius, we can find the circle. Okay, we'll be able to find it. Now, those are just different types of questions. So they can ask a lot of different ones. Let's keep going. It says the diameter is 20. What is the angle measure with an area of 10 pi? So let's say we go through that one. Let's say we missed that one. Okay. It's going to tell us the diameter is 2 times the radius. The radius is 10. So the area is pi r squared. So we're able to find it. So you should get through those. Those are all different. Again, it says mixed review. So you're going to get all kinds of different questions. You get one like this. 85, 120, 90. What's the missing angle? They got to add up to 360, right? So these are all the different types of questions that you may see as you go through the mixed review today for IXL.